Gently move it through ways.
I did mention the area we are looking at is the principle of stratigraphy, principles of stratigraphy, and the slash principle of historical geology. Principles of stratigraphy and historical geology. So you can just trace it. Now, I remember telling you last week that you have sediments, and from what do I call it now? From the knowledge of weathering you have, you would have been told that sediments are generated from pre-existing rock. True or false? True or false? Now, when they are generated, those particles generated will be moved from that source from where the process took place. They will be transported, they will be deposited. And I did demonstrate. Oh, it wasn't last week, that was 2 weeks ago. I did mention that what is transported and deposited is a function of so many factors. And one of the principal factors is the availability of hello, yeah. Mo wà ní master's class. Okay, ṣé kọ́ wá gbọ́ mi bí báyìí àbí báwo àbí kọ́ wá gbá kí? Okay, no problem. All right. So, I said those sediments are being transported, and that the factor determining what is being transported is the availability of the bed load or the sediments that are generated. Again, it's equally a function of the transporting medium, and the transporting medium is a function of the geographical location. What is responsible for sediment transportation in a temperate environment is different from what is the transport medium in the polar region. It's equally different from what is the principal transporting agent in the arid. So it's a function. But let's just assume that what is obtainable in our area, sphere here, is what is generally obtainable all over the world. Of course, that's not right, not true, so to say. But we are just using it as an analogy. So in this part of the world, the major transporting medium is water, which you refer to as a fluvium. So those sediments, because of those factors I've listed, you discover that you won't just see a certain volume, massive volume, that will just leave the source point and get to the depot center and just get there. And you see it maybe about a 3, 4, 5, 6-story building in height. No, it's a sequential thing. And what determines the sequence or the sequences is all what I've listed. So, if let's say in this cycle, sediments are generated, the transporting agents are there, they move the sediments, they take it to that depot center, they will deposit there. If peradventure, the supply of the sediments is high frequency, and then the material, the agents moving them is equally there, then you see it, having been deposited there okay, yeah, okay. Anyway, drop it. Share more like crazy. Okay. So, That is how you find it. Now, based on all these analogies I've mentioned, you now discover that since it's not common in nature, it's more or less not happening in nature to have such a massive material being carried from the placenta and then dropped there, and then you have it in the like a Mount Kilimanjaro like that. So let's just now confine our reasoning within the context of the fact that okay, they are being dropped bit by bit. So the first bit, this is our depot center. I illustrated this last time. So let's say within that depot center, you have this as first deposit. So maybe it takes some little time. You have all those things. If you have gone through that, you see something like that kind of technology. So this one will form a layer. That's the first cycle. It forms a layer. So another one will come later. Another one will come later. Another one will come later. All these things, they are recording what you refer to as geological events. So, as events are going on in the geological world, they are being recorded there. How are they recording them? We are not talking about having a tape recorder there, but this geological tape recorder. The things that are taking records of those things are referred to as the fossils. And that is why Dr. Bankole started. Okay, Doc. That's why Dr. Bankole started by teaching you the applications of the fossils and the evolutionary theory. So those fossils that you have embedded within the sediments now keep time. The ones that are taking record of the time. In fact, rock are referred to as geological clock, especially this sedimentary one. So they are referred to as geological clock. So you can go there, you can unravel and tell you, oh, this is an event that has taken place in the time past. Also, when you have these sediments in that order like that, to study, when you go there, when you want to look at, okay, what are there? And that singular act amount to study of those layers. And the act of studying those layers is referred to as stratigraphy. In other words, stratigraphy is the study of layered rocks, layered sedimentary rocks. Is that understood? Yes. Do you understand all my rhetorics now? Yes. Do you understand? Yes. Do you understand? Yes. Are you sure you understand what I've said so far? Yes, sir. So, and I equally mentioned to you that studying that or those layers require different approaches. And most often, they are the total makeup of those materials, of those layers that are used. One of such is the fossil. And those fossil could be macro, could be micro. I want to believe you are doing macro paleontology now. Yeah. At what point are you going to do it? Which level are you? Oh, sorry. 100. So when you are at 200 level, you are going to do macro paleontology. Is that understood? Then you're talking about maybe all the teeth of some of these giant animals, like the dinosaurs that has gone into extinctions and the like. So we have the ones that are vertebrates and the invertebrate ones. So on the 300 level, you'll be looking at the micro. Those are the very tiny ones that require you eating your eyes. Is that understood? But Dr. Bankole would have mentioned it. I want to believe now, at least for now. So you can make use of those fossils. You can make use of the lithological characteristics of the sediments. That understood. In some cases, you can carry out some chemical study, which we call the chemostratigraphy. Then, if it were to be where you have volcanic ash, you carry out what you call the tephra stratigraphy. And if you may choose to use the seismic, for those of you in the geophysics, and that we have the seismic stratigraphy. So we have varieties like that. Is that understood? So, but as far as this one is concerned, as I said, and then based on the title, stratigraphy and then the historical geology, we those principles. Last time we started looking at them, and I think the first one I mentioned was these principles of what it was it? Yeah, I mentioned that one, and after that I mentioned another one. I mentioned that, and that one was quite exhaustive. I was trying to tell you how that principle could be applied. Because it's a principle with a proviso. Is that understood? It's a principle with a proviso. It has a conditional term attached to it that provided. That word provided. That is the proviso there. Provided. So it's not a jealousy. Kí ìwé wọlé èyí tẹ́ bá mú lọ́dà. Sí ọ́fíìsì lélẹ̀. Ẹ̀dẹ̀ lè ṣe ń sìn. Ó yí. Kí wàá lélẹ̀? Nǹkan tí mo fẹ́ gbé síbẹ̀ náà rẹ̀. Òun ní ìbàdàn tí mo gbé. Kí ló wá wà ń bẹ̀? Aṣọ fún Dr. Bankole. Ẹ̀pà fún Dr. Ìjẹ́kúnlé. Just a minute, please. I'm trying to just give you that slide. So today we want to go much further and see. Hey, Abdulatif, how is your program tomorrow? How is your program tomorrow? Yes. You don't have anything tomorrow? Don't mind them. If you don't have anything, just let me know. Do that. So, go to when 2 to 4. What do I keep there? Why are you telling me what we have? Did he ask for this information? So, go to the first slide and to the first slide. Are you there? So, there, the following are listed. We have stratigraphy, the basic principles of relative dating, unconformities, correlation of rock units, absolute dating, and geological time. So, really, some of maybe let me just the dating, the relative dating, or let's say the stratigraphy, the relative dating, and non-conformity. Perhaps correlation. We can look at it. Then geological time scale. Whereas the aspect that is somehow historical there. So we can flip through, but essentially the first 3 bullets is what we are going to be looking at. So what is stratigraphy? As we said, it's the study of rock layers and their relationship with others. So it provides simple principles that are used to interpret geological events. Provides simple principles that are used to interpret geological events. Just as we said then, that when you see layers of rocks, provided they have not been distorted, they have not been deformed, that they are still retaining the first position when they were originally laid, the ones at the bottom should be the oldest. That proviso is still holding. Is that understood? So that's how you use your stratigraphy to do that. Now go to, you can see some rock units there. Can you see it? You will see some that are layered, you see some that are massive. The ones that are massive, they are the crystalline rocks there, whereas those that are layered are the ones that we're talking about. This falls, what you are seeing there falls under the unconformity. When we get there, I will explain much better. So, what are these basic principles? Number one, we have the original horizontality, we have the superposition, we have the fauna and the flora succession, we have the cross-cutting the relationships. Then you can have some principle of inclusion too. So, but basic ones are the ones we have there. So, what is the principle of original horizontality? It states that sediments are generally deposited in a horizontal position. They are generally deposited in a horizontal position. The word horizontal is not the same thing as it's parallel. Do you understand? See, your basin, definitely a basin has a geometry. That's the shape. So the shape may be somehow like this, right? That could be a possible shape of the basin. Huh? So when you have your sediment being brought in, you have them like this, you have them like this, and all like that. That's a possibility. You can equally have your basin to be like this, like the one we have there, right? Is that understood? When you want to look at it, the surface of the earth is planar, like where we are. So sediments can be deposited parallel to it. It can be deposited diagonally to it. Is that understood? Something like this is diagonal. Something like this is parallel. Is that understood? However, those layers, they are horizontal. You see them in lines like that. Do you understand?
Yes, sir.
Is that understood?
Yes, sir.
So layers are deposited. That is what the principle is telling us. They are horizontally laid like this. That is the way you have layers being deposited. And most often, that alignment is based on the shape of the basin geometry. It's based on the shape of the basin geometry. Do you understand? Do you understood?
Yes, sir.
If you have your basin in a warpy form, you still have those sediments aligning with that shape. The only thing is that you won't find them in a straight line like this. Is that understood?
Yes, sir.
So if we observe rocks that are folded or inclined, they must be with exceptions. Maybe before you have them in that case, something must have happened to them to have been folded. But originally they weren't like that. So as events unfold, you start having some changes in the ways they are. So look at the next slide again. You see another layer that are inclining there. So the statement below says most layers of sediments deposit in a nearly horizontal position. Thus, when we see inclined rocks layers as shown, we can assume that they must have been moved into that position after deposition. Is that understood? Is that understood?
Yes, sir.
Meaning that originally they were not like the way they are inclined. But after that deposition, something must have possibly happened. Last time we were talking about a recurrent fold that could negate the principle of a superposition. I mentioned to you that, of course, what brings about folding is as a result of tectonism. arc movement. In the situation where you have upliftment and then you have folding. So what was originally horizontal can become compressed. And if it's not, if it is competent, it folds. If it's not competent, it breaks. And that breakage is called fracture. And fracture can happen such that you can have the two ends or different ends still maintaining that position, but you have a breakage there. In that case, we call it joint. But when there is a displacement, we call it fault. Is that understood?
Yes.
Do you understand what I'm saying?
Yes, sir.
So, for that recurrent fold, because the makeup of the rock unit is competent, they can soak the pressure, they can soak the force that is acting on that particular rock unit at that point in time. Instead of breaking, they will fold. And I think it is this class. The folding could be up, it could be down. If it turns up, the shape it forms is called the anticline. If it turns down, the shape formed is called the syncline. I said the force acting on that particular rock unit, right? That if the rock unit is competent enough, it will soak in that force, the pressure, so that instead of breaking, it will fold. And that fold, the shape could be upward, the shape could be downward. That if it is upward, you call it anticlinal. You call it anticlinal fold. If it is downward, it gives a fold called synclinal. Is that understood? Do you understand that? So assuming you have a synclinal and anticlinal fold, you are having two limbs. Mind you, they were originally like this. It was originally like this. But the force is acting here, the force is acting here. So it can compress such that you have it bent like this. So that's anticlinal. Now, if the force acting here and the one acting here, if they are equal to each other, the dip of this limb and the dip of this limb, they are equal. So if this one is deeper at 45, this side is equally deeper at 45. In situation where you have that kind of anticlinal fold is called a symmetrical fold. Symmetrical fold. So for a symmetrical fold, a limb here and a limb here, they are dipping, having the same quantum of inclination. Do you understand? Is that understood?
Yes, sir.
Such that if you cut it from the axia, that is at the crest, if you cut it into two, vertically, they become mirror image of each other. What you have here will be similar to what you have here. That is what we call a mirror image. Is that understood?
Yes, sir.
Right. But if you are now having a limb having a greater angle of inclination to the other, it's no more symmetrical. It becomes asymmetrical. So a time will come that asymmetrical fold can continue folding, especially if the force is still acting on it, to a point where you have the axial plane that was once vertical tilting gradually to a point where you have the axial plane parallel to the horizontal. Is that understood? Huh? So when you have that, you call it a recurrent fold. So a recurrent fold is more or less called a slipping fold. It's a type of fold where the axial plane is horizontal or parallel to the horizontal. Do you understand?
Yes, sir.
So if that happens, are the agents of the arch movement still acting on it? Essentially, erosion activity. You just discovered that a time will come that half of that fold is washed up. Erosion will remove it. So if that happens, maybe it took several years to happen, and you get there in your own generation, you just be able to feel that you saw it like that. Yes, what will come to you, yes, you have having some layers there, the principle of superposition will come into your mind that, okay, that the one at the base is the oldest. Then you must be making a mistake. Because to you, that is what you are seeing. But in reality, that is not how it should be. And the only way you can possibly unravel that is making use of another principle. So at times, one principle may not be able to be used to put the geological event in an accurate perspective. Is that understood? Yes. And I remember I mentioned there that when you have situations like that, the principle of floral and fauna association will come. In fact, it's the best that we can use. Because what is that principle itself? It tells us that you have organisms that they follow themselves in a definite and determinable order. That is what Dr. Bankole has taught you. Evolutionary theory. You discover they are coming from a very simple to complex. Is that understood? Yes. When you look at, with the little knowledge of geological time scale, you discover that the Archaeozoic, we have the Proterozoic, the Archaeozoic, we have the Proterozoic. The Archaeozoic is lifeless. You won't see anything, be it plant or animal. But when you get to Proterozoic, you are now seeing that's of the Precambrian, you are now going to be seeing some traces of plants and animals. But the best plant you can possibly see there, they are the phylagenous types. That's at the algae. Then you maybe see some animals like the trilobites around that age. But as you are moving up, after 660 million years of that table, you start seeing some lives, some shrubs. You are no more seeing all those flowerless plants. You are going to be seeing flowering plants now. Those are the plants with shrubs that can grow into very massive plants. You understand? So, and that is that order until you see the giant reptiles now going out of extinction, going into extinction. Then you start seeing the evolution of sapiens, if almost, until you now have mammals. Is that not what you were told? Is that not what you were told? Yes, you are not, even the one I'm telling you tomorrow, now you say you didn't tell us. Go and read it. That's the Darwin evolutionary theory. Charles Darwin. So go and read it. So, the next slide is telling us the principle about this principle of superposition. We are going to look at this thing, don't worry, we are going to see them in a diagrammatical form, so you appreciate it the more. So, that one tells us that in an undeformed sequence of sedimentary rocks, each bed is older than the one above and younger than the one below. Do you understand that? Yes. Each one is older than the one above and younger than the one below. So, as you have all those sequences, this one is older than this is older than this is older than this one is younger than this one is younger than this one is younger than this. Is that understood? Yes, sir. That is, if it has not been, the setup has not been deformed. So look at that principle of superposition. That's what I was trying to tell you, where you have sediments being moved from the source point to the depot center. You see the first cycle, that's time 1. Can you see that? The second cylinder, time 2, you see that pinkish cycle on top of the milky one. Then the time 3, you're having 3 layers now. So you have the oldest and then the youngest. The oldest, the youngest. If it were to be that pinkish, you say that's younger. So that is that. And you can now see the feed relationship of such. Are you with your slide? Are you looking at?
Yes, sir.
Come. Where's your Android? Yours, no? It's dead. Dead. The language you use scared me. When you say it's dead, I only know that it's animals and human beings that die. So, but for those of you who can have a pictorial view of yours, you will see classical examples there. We have the Supai group, we have the Ahmed Shale, we have the Kokino sandstone, we have Torowi formation, and Keba limestone. So, these are different layers. And from what we have just learned, which one is the youngest here? Which one is the oldest? Which one is oldest? The one that is youngest is what? To your right, when you look at it, you see a pattern then there that is showing the direction of younging. That means as you go, you are moving up, it's getting younger. Is that understood? Yes. So next slide. Yes. Which of these slides?
According to the definition, you said this philosophical position states that the one under is the oldest.
Yes.
And the one above is the youngest. But like the thing is elevating up, it's coming from the ground. That means there might be a time whereby it's only just a layer that the floor. And then it raises up and rises up. But if that layer was on the floor before, then that was the oldest before. So if it goes up, it's not still going to be the oldest, because like another one is coming up.
See that if I got your question very well, you are saying that as you have it elevated, right? There is time may come that the ones on top will not be there.
No, like before it was the layer that was there before.
Yes.
Like the layer was the oldest at that time. If it goes up, it means there's another layer that came to this.
At the back, at the base?
Yes, sir.
No.
But in this diagram, the second pictorial diagram, it says
Show.
there's like an elevation.
Let me see. Don't just show me there. The one we just check now.
It's not an elevation, it's just something.
Oh yeah, I'm listening to you.
It is showing that there are different layers.
Yes.
It is things that
It means there was a time whereby it
not
was
about
only a layer,
depositing.
Yes.
and that layer was the oldest.
Yes.
Things that is going
Another layer will pop up.
Yes.
That means
No, it
another
won't pop. It won't pop up. It will go. It will come on top.
is depositing.
It's deposited on it.
I thought so.
No. You see, just like what we said earlier, that you have sedimentary, that is source point where those sediments are generated, and they are after weathering, that sediments are generated. Then you have another process called transportation, and by the end of erosion, they are now moved. You understand? So the first set of sediments that are moved, deposited. So if there are other ones that are generated early enough again, and the transporting medium is there, you have it again, move over. So you are having, it's a continual process whereby as many cycles as you are going to have, it's going to be equivalent to the number of layers you will have as well. All right. So cross-cutting relationship. Principle of cross-cutting relationship. The principle says that when a fault cuts through a rock, or cuts through rocks, or when magma intrudes and crystallizes, the word intrude, underline, or when magma intrudes, there must be something that is being intruded. Is that understood? There must be something in place that is being intruded. Do you understand that?
Yes, sir.
We'll still go back to that later. So, and crystallizes. We can assume that the fault or intrusion is younger than the rocks. I said earlier that something must be there to be intruded. What is there to be intruded is younger than the event that has come to intrude it. Is that understood?
So I don't understand. Sir, what he came to
What has come to intrude that particular thing is younger than what it has come to intrude. This, for instance, this table has been here. Maybe it has a sticky body and a lizard just come and climb and get stuck there. Is that understood? It's an intruder. So which of the two is younger? It's the lizard. Is that understood? Again, what is faulted is older than the fault itself. The thing must be there before it can be faulted. Is that understood?
Yes, sir.
The thing, that object must be there before it can be faulted. So that means relatively it's older than that event that took place. Do you understand? That an event is faulting. Do you understand?
Yes, sir.
So it's getting a little bit complex, but yes, go to that next diagram. Are you there, please?
Yes, sir.
Very important. You must all be there. So this is a cross-cutting relationship. An intrusive rock unit is younger than the rock's intrudes. It intrudes. A fault is younger than the rock layers it cuts. Those are the things we have said, and it's put in a better perspective now. Look at how many layers of sediment rock do you have there?
I think this is the fault. I think this is not supposed to be here.
How many sediment layers do you have? 10? Where did you get 10 here? How many do you have? You have 9. 9 sedimentary layers. 9 sedimentary layers. Now, these sediments, generally they are referred to as clastic rocks, especially the bulk of it, up to when you get to the surface. Maybe the last one, two, three, four. Yes, the fourth to the last and second to the last. Those are the only different. But in sedimentology, we call them what? This fellow has said. What did he say to me? So, as I was saying, what's wrong with where is that Latif? What's wrong with it? He sent a message and deleted it. Something is wrong with him. So, you discover that bulk of what you have there, they are sandstone. Then you have conglomerates. Then you have shale, and you have seals. Now, let me ask you, what is a seal? Yes. What is the characteristic of a seal? Yes.
It's when magma comes, like the eruption lies with the
Yes. We use the word concordant. It's in concordant with the layers. Is that understood? So when you have a discordant, that is what you call the dike. Exactly. So it cuts through. So whereas that one will come, but it aligns on the layer. So you say it is in concordance with what is there already. So now how many deformation, how many faults can you identify here? How many intrusion have you identified? That is a form of dike now. Then there is an intrusion that is bigger than the seal, that is bigger than the dike. It's called batholith. How many do you identify there? 1. Right?
Yes, sir.
So, what you are seeing there, based on the principle of cross-cutting relationship, you can now order the sequence of events there. Do you understand?
Yes, sir.
You can order the sequence of events, how those events started, the one that first came into being and the one that came last. So look at it very well. I want an intelligent person here to stand up and tell us the sequence. All you need to tell us is, okay, we have sedimentary layer, we have this dike 1, dike 2, seal, batholith, just the way they are ordered there. So let's look at it together and let's talk.
I understand that for it came to place. When I usually have came down, usually have social and they started from the surface. How of course
Oh yeah, who wants to tell us?
so you place the layers down, so the layers act like and then it came immediately what this
Who wants to tell us?
and the other
Who wants to try?
let's explain this. For this one, I feel this should be old.
Now, listen attentively to me. Listen attentively. As I said earlier, the bulk of sedimentary rock you have here is sandstone. Look at it very well. The bulk of sedimentary rock you have here is sandstone. There are 3 sandstone units. What are they? I mean, 3, what did I say? 3 sedimentary rock types. What are they? Yes, sandstone, shale, and conglomerate. Now, of the 3 you have mentioned, which one is the oldest? So, just stop there. You know that sandstone, of all what you have here, then, is the oldest.
So that one starts from the ground according to the diagram.
So what in your own view now? What one are you saying? Batoli is older? We just said something here that what is being intruded is older than the intrusion. Is that what we said? So if sedimentary rock is not there, there is no way. Look at that sedimentary rock. Look at it very well. You would discover that it's an intruder. And how did I know that? You said what? How did we know that? It's cut across the sandstone. It cuts across the sandstone. And you will now discover that, yes, you found that you mentioned that batholith. You can even start your your order of event there. Look at it very well. There, aside the sedimentary rock that is there, that sandstone, there are 3 events that took place afterwards. Can you name them? The batholith, the dike, and the fault. Now, of those three events, which one is the oldest? You are right. You are wrong. Huh? It's the fault. It's the fault. Do you agree with that? It's the fault. Because if it's not the fault, you would have seen that line of fault cutting through it. So it was after fault has taken place that you have the intrusion. That's why it's sealing it. Do you understand that? Now, you have unraveled one. It remains two. The fourth and then the dike B. So, which of the one that is younger and older? You have talked about Bartoli now.
Fourth A and dike B.
Okay, yes. Okay, you said the fourth B is the oldest. Followed by what? Followed by what? Followed by what? It's followed by Bartoli's. And then you have dike B. Now, we have successfully carried out that one. Now, let's look at Fort A and Fort B. Fort A and Fort B. In Fort A, which of the two forts is older?
Fort A.
Why?
Because it doesn't start all the way from top. While Fort A started
Is that what?
Fort A started when the sediments were still being deposited.
Which one?
While Fort B started after the
Is that what?
layers have been deposited.
Yes.
While Fort B must.
Yes. See where Fort A terminates. See where Fort B terminates. Can you see? Fort B cut across the entire layers. Whereas Fort A gets to where you have the terminal of your sandstone and terminates. Do you understand that?
Yes.
So now, put the event before we at least the first set of event. Now I want somebody to stand up and tell us the order. Oh yeah, now we have done bulk of it. What is it?
Oh, there's
We have the sandstone, right? We have the sandstone. We have Fort A. All you all need to do is to bring the event that's ordered there. You put it on it. That is still the event of the dike B, Fort B, and then the battle. And we said earlier that Fort B is older, is the oldest event there. Is that not it?
Dike B is younger than
I said on this side.
But it's cutting across the line. So it means that when the layer
It's on this side.
That's
So can somebody try?
Dike B. I feel this Bashman, I don't know how to pronounce it, is the oldest. One dike B should be the second oldest. Because it started on this see. Look at from see the youngest. This was B. I don't know.
No, Fort B comes before what?
If it goes to the entire thing, must mean that after the entire thing has been set, that's when it goes through. I look at the way you explain 14. So that if 14 started within the terminal.
Yes, if you want to put the event in the other place.
Yes, it's happening after the 14. How do you happen?
Oh yeah, start.
Literally cutting through.
Fort B, followed by dike B, right? That is what you're auditioning. Now, we identified that Fort A is older than Fort B.
Yes, sir.
So if you now want to, and sandstone is the oldest of them all, put them in that perspective and tell us. Let somebody stand up and talk.
A, Fort B, dike B,
Give it a try.
Sandstone occurred, then Fort A.
No, say it out.
Okay, sandstone occurred first, then Fort A occurred, then Fort B occurred, then we had the battle, then dike B, then the shell. Sorry, then the conglomerate.
You discover that for the V cuts through conglomerates. It cuts through conglomerates.
The oldest is sand. The
Okay,
oldest is
before the
sandstone.
fourth sandstone of fourth A.
Some of you are not thinking. You are just looking. You are expecting others to think for you.
Then batholith occurred. Type B occurred. Then conglomerate occurred. Shell occurred. Then fourth B, then the seal occurred then.
Your C is a product of type B.
Okay, product of type B. Let me repeat myself.
Repeat yourself.
Sandstone occurred, then followed by fourth A. And after fourth A has occurred, then batholith occurred. After batholith occurred, type B occurred. Then conglomerate occurred, followed by shell, and fourth B. Then cut across. Then fourth B cut across. Then we have type A also.
So
cut
the youngest of events here is what?
like A. Like A is the youngest.
Yes.
Like A is the youngest.
Oh yeah,
Like A is the youngest.
that is the youngest.
So you identify the youngest, you identify the oldest. Then in between now you now fix the events. Yes. You want to do what? You want to? Okay. Okay. That means you are this people. What is it? Try. Oh yeah.
So what I'm thinking is Sanskrit first, then fourth A upward, then this thing, what's the conglomerate? Then after the conglomerate, the shell. After the shell,
You have conglomerate.
yes. Because for
Wait.
fourth B to
Where is the terminal of Fort A?
fourth A end before the conglomerate. Then after fourth
So you have sandstone, you have Fort A,
Yes.
you have conglomerate.
yes, sir.
That's your submission, Abi?
So what I'm thinking is that since
No,
the-
continue.
after the conglomerate is the shield.
But okay, continue.
Then fourth B occurred. Then we have the batholith. Then type B. Then type A.
Look at the seal.
Oh, sorry, I missed the seal.
Look at the seal and the conglomerate. Which one is younger?
Oh, I think the seal is younger than the older than the conglomerate. Seal is younger than the conglomerate.
Seal is what?
Younger than the conglomerate.
Are you sure?
Okay, so it's coming before. So that means fourth A, Samsung, fourth A. That means that B.
All right. Sit down. By next class, where is your class rep? You sent me a message and you deleted it twice. Hello.
Let's do the fourth.
See, I'm giving it to you as an assignment. The next class, Abdul Latif, you are going to collect it. Then this is the way you are going to collect the assignment. You collect for geology. Don't let it mix with geophysics. Is that understood? Do you understand me? Let me warn those of you who are fond of cheating. You can never escape this kind of scenario in the exam. I'm telling you now, it's a life question. So if you like, don't make use of your brain. Because I'm going to give you a more complex one. So if you don't understand a simple one, come and tell me the way you do a complex one under exam condition. So sit down, unravel this thing based on those principles, come up with the right sequence, and it will be graded. I can assure you, it's going to be your CA, part of your CA. Let me put it that way. So if you like, use your lean or mean. What do you use that one? What's the problem? Which version? On this one again? Which one? What? Eh? Don't worry. Hey. Let me tell you, if you are, the way you are going to die is listening. Sandstone, conglomerate, dike A, dike B. And you're listening, and then let me tell you again, because we are applying principles here, the oldest must be the last. Do you understand? In your listening, the oldest must be the last, meaning that you are going to start with the youngest event. So let's go to a more challenging geological event. Unconformities. We have markers of mixing time. So when layers of rocks formed without interruption, we call them conformable. When layers of rock formed without interruption, we call them conformable. See, we said something. When you have sediment generated, transported, and deposited. And I did mention to you, when those sediments are moved, they are not moved in isolation. They are moved with all organic materials, including the fossils, as they are being moved and deposited. And we have said, from the flora and fauna succession principle, that those organisms are formed in a pattern that is determinable, and they are well structured. You have a regular sequence. The one that is supposed to form at this particular time will be formed, followed by the one that will form later. And that's what brought about the evolutionary theory, as we have been talking about for some times now. Now, when you are on the field and you are sampling, the possibility is there that as you are sampling, you are seeing a very massive gap. Right? You are having a massive gap. When you look at your Proterozoic, for instance, your Proterozoic is subdivided into different epochs, starting from the Cambrian and then ending at the Carboniferous. Right? Within it, you have the Silurian and the others. So, if peradventure you are seeing a layer containing Cambrian fossil, overlying layer containing Cambrian fossils, you know there's a huge gap there. Do you understand what I'm saying? At least you have seen your geological time scale before. Have you seen geological time scale before?
Yes.
You are going into panic mode now. Or what do I call it? You have seen geological time scale before.
Yes.
In your geological time scale, that geological time scale is subdivided. True or false? So what are the subdivisions?
Chaos, era, period.
And what? We have eon, we have era, we have period, we have the epoch. So the epoch that you have for your Cambrian, for your Proterozoic, I've just stated that you have at the base there Cambrian, you have at the topmost there Carboniferous, and then you have some other subdivisions there. If peradventure the one that is the youngest is overlining the one that is oldest, what should occur to you that there is a huge gap. Something is missing. Is that not it?
Yes, sir.
So, when you observe that, you will say that those layers are unconformably overlaying each other. However, if the sequence is intact, they are conformably. Right? So, that unconformably is referred to as unconformity. It's a break in stratigraphical column. It is referred to as a period of non-deposition. It is equally referred to as an erosional surface. And if it's an erosional surface, that means erosion has washed off what was there before. Is that understood? So there is no information to be gathered there. Is that understood? Yes. This unconformity, there are 4 different types. We have the disconformity, we have the non-conformity, we have the paraconformity, then we have the angular unconformity. Do you understand? I list them again. 4. The non-conformity. You are stupid. I'm saying something, you are telling me there is 3 on this. You are a stupid boy. And when it is in the exam, say the student that is listed. We have the non-conformity. We have the disconformity. We have the angular unconformity. Then we have the para-conformity. The para-conformity. Now, the non-conformity is that erosional surface existing between layered rocks and the crystalline rock. That is, you have layered rock, you have the crystalline rock. Those are that granitic body or metamorphic body. Those are the kind of rock referred to as crystalline. So when you now have layered rocks now overlaying it, that particular surface at which we have the contact is referred to as a non-conformity. Again, you can have a non-conformity between layered rocks, but those layered rocks are of different lithologies. Right? It could be a surface between shale and sandstone. It could be a surface between sandstone and limestone. So that is disconformity. Para-unconformity. That para is a layer, erosional surface that is existing between layered rocks that of the same lithology. Para is the type of unconformity existing between 2 layered rocks of similar lithology. That is, for disconformity, I told you that it of different lithology, shale or possibly sandstone or possibly limestone. But in this case, the para will give you have shale, you have sandstone, you have sandstone, you have limestone, you have limestone. Is that understood? That is para. Again, how do you resolve the problem of para? Because on the field, you may not even be able to pick it. There comes again the principle of floral and final succession. Because their fossil content will let you know that, they are not deposited at the same time. They are not of the same age. Is that understood? Yes, the last one is called the angular. It's called the angular. Imagine a situation where you have the sedimentary rock that are tilted. A, B, C. Right? Or possibly it was a sedimentary inflow before. Right? And for one reason or the other, earth movement and then whatever thing, this place has been cut off, and then you're having something like this left. Right?
Yes, sir.
So, and after this event comes another event. You now have layer rock now being deposited on it. So this type is called the angular. This is why it is angular. Can you see? This is anti-inclination, this is parallel. So because it is parallel, and this one is angular, as dipping, we call it an angular conformity. Is that understood?
Yes, sir.
Do you understand that?
Yes, sir.
Later when you get to maybe 400 level now, since your curriculum is different, you appreciate this one. It's one of the structures in petroleum geology that houses hydrocarbon. So it's of great economic importance. Is that understood? Yes. Don't worry, we won't talk much about that until when you are mature. At least to assimilate it. So let's quickly go through that one and then we call it a day. So an angular conformity consists of tilted or folded sedimentary rocks that are overlain by younger, more flat line strata. That's what we demonstrated there. So it indicates a period of long period of rock deformation and erosion. You can see, look at the first stage there. You have the deposition. You see they are horizontally laid. That is event A. Event B, you have them folded. Can you see? Event C, you have erosion activity now. It has carved it to that particular topography. Then you have the last one. You have the subsidence and the renewed deposition. So what you are now seeing there, you can see the folded beds there now. And because it is submerged under the sea, you have sediments now being developing on them. Is that understood?
Yes, sir.
So on the field, at least the one you saw there is a pictorial view, but this is a reality. You see this one, angular conformity at Sika Point, southern Scotland. So that is according to James Whitting. In fact, he's the father of geology. These are the people that came out with those principles. So that is that. Any question? Question. Oh, please, let us. I want us to quickly run through the unconformity and we'll stop there today. So we have the disconformity. The disconformity. I've told you what the disconformity is. Layer blocks. So, and this is a disconformity type. You can see it. You have Devonian. See Devonian there. See Jurassic. You can see that period very well. So look at this one. Another disconformity. So now see non-conformity. You have intrusive igneous rock granite. Then you have the sedimentary layers there. So these are very common in our area here. By the time you go for geology of Nigeria, you see several of that. In fact, those of you from Jebu waterside there, you see one at J4 side. We always about 3 months back when we took the final year students, we were there to see that. So it's a very common one around us here. And if security situation in Nigeria would have improved by the time we did geology of Nigeria, it will take you to much better exposures, especially in the south. That's the Gara axis of Edo State. We are going to see beautiful geological structures there. So here we have the non-conformity, we have the intrusive contacts. So I think you can look at that one on your own, and by the grace of God, we will be looking at other challenging cases, and that would dive into the historical geological aspect of it. So any question, please? Before you, Abdul Latif, you didn't resolve. Okay, you are saying tomorrow is not possible. So, God's willing, we meet next week, Tuesday. Since tomorrow is not work, it's not workable. Abi, is that what you said? When on Friday? When is it? Let's see if he is going to. If I will be able to make it, I will let you know. If I'll be able to make it, I will let you know. I'm trying to compress so that I won't have more than one more class today. So that others can come. Time is not on your side, though.
Yes, sir.
So because the other aspect too is a little bit voluminous, but you see how we can compress it. But at most, let's say 2 classes. And see, that does not mean you cannot go ahead and call the next person. It can be taught in parallel. Do you understand? Where is your no? Where is your assistant? Where is she?
Frost.
No, are you a lady or a boy? Come, is that lady not here again? Where is Jovis not supposed to be here?
She's a course rep of Jew.
Is Jovis student not supposed to be here?
Yeah.
Where is she?
She knows it, but that's her assistant.
But the assistant is coming and there.
Forget about assistant. I want to see that girl. Where is she? I've been asking after her all this while. What's wrong with her?
I think she's feeling
Eh?
you don't know what's happening.
This problem. For how long? Since last semester? That can't be an ordinary tutor problem. That's a serious one. Have you called the attention of the department to that? Okay, go we are. Just extend my greetings to her. That I wish her quickest recovery. So, let's just yes. What I wanted to yes. Which one do you want to do? My friend, it is an assignment. Go and use your brain to unravel that. That's the assignment I gave to you. Were you not here when I was saying it? I said that particular event is the assignment and that you should collect it. So we've not even left here now, you have forgotten. You are going to collect it such that where is Jovis's class rep? However, whether assistant or whether. Where are you? Mr. Van, you collect that of Jovis's and you write the names of those you have collected, and it must be in tandem. Not that you collect, you have 10 names and you are bringing 12 I will cancel your own there. Is that understood? So whatever you have, it must correspond. Same thing applicable to you. So, yeah.
You said something giving back to
Huh? What is your question? What is your question?
You said cross. I refer to as theological cross. Why, sir?
That I recall. You see, there is one major principle that I'm going to mention to you as we are progressing. It's called the principle of uniformitarianism. Principle of uniformitarianism. It's a very simple principle, and it states that the present we are now is the key to the past. Right? Events you are witnessing have happened in the past. So what you are seeing is just to mirror what has done, has happened in the time past. I have told you that the principle of, the evolutionary theory states clearly that you have all these evolutions, this material, be it plant and animal, evolving from the simplest to the complex form. And in the geological record, you have all these organisms occupying a particular period of time. And their relics are always buried within the rock unit. Is that understood? And the more reason you are talking about fossils, we talk clock. Clock is the same thing as time. Clock is the same thing as age. All we have been talking about since, they are called relative age. So those principles actually address the relative dating. That is why, when you look at your geological time scale, an aspect, that is the left side aspect of your geological time scale, deal with the relative dating, the relative age. The last column to the right is called the absolute age. It gives you the exact age in numerical form. I said it then, and I'm repeating it based on your question now. Maybe you are not here, or you were here and not here with your mind. That this superposition theory or principle tells you that the ones at the base is older than the one at the top, meaning that it's older. The age, how old is what you don't know. And that's why you call it relative. However, the absolute age will tell you that layer A is 6 million years old. Layer B is 4 million years old. That is definite, that is absolute. And what did they use? They use the radiogenic material there, what we call the radioisotopes. Is that understood? Do you understand that? So all these things are embedded in the rock. That's why you can say the rock is giving you, it's acting as a time, geological time. Is that understood? Do you understand that now?
Thank you, sir.
Where's my friend? Come and take it. You bring it. Don't lose it again. You want to be buying every day. Are you a politician? Come, where is my attendance sheet?
Sir, the attendance.
Which one is it?
Sir, it's body
Eh? Why you? Come. Why are you moving it up? Give me your bag. Where is the other one?
Sir, this is your budget.
We just send an invoice later.
Sir, this is your level.
Together.
Yes, sir.
I mean the first one.
Okay, first attendance.
But this thing, you have to separate it into how many are you?
Sir, I think 90.
90. So geology is how many?
47.
So
You already have more than this.